Alrighty, so 1-6, or the section 6 problems, are just like 1-5, where we're still simplifying rational expressions that contain negative exponents. So this is really just going to give us more practice in a variety of problems. We only have 3 examples here today, but it is very similar to what we did in 1-5 yesterday or today in class, where we want to get the negative exponents to their denominators, and then depending on the result, we'll either have a complex fraction or just a rational expression. So the first one I want us to try simplifying. So that's going to be our directions for all 3 of these. X to the negative 1 minus y to the negative 1 over x to the negative 2 minus y to the negative 2. So first thing I'm going to do is take the negative exponents and move them to their denominators of each expression. So x to the negative 1 becomes 1 over x, y to the negative 1 becomes 1 over y, and in the denominator 1 over x squared and 1 over y squared. Okay, once I have that, I'm now going to look for my LCD and multiply everything in the expression by the LCD. So in looking at my denominators, I have x, y, x squared, y squared. So my LCD is going to be x squared, y squared. So I multiply each term by x squared, y squared. So when we do that, the x will cancel with one of them there, so I'll have xy squared minus, and y will cancel with one of the y's, x squared y. So now my denominators on the numerator are gone. In my denominator, the x squared goes away completely, and on 1 over y squared, the y squared goes away completely. So once we have our expression simplified down to just a rational expression, I'm going to now factor my numerator and denominator so I can see if anything will cancel. So we have x, y as a GCF on top, leaving me with y minus x inside the parentheses. On the bottom I have a difference of squares, so y minus x, y plus x. Here is where I notice I have a polynomial that I can cancel out, giving me xy over y plus x as my final simplified answer. Okay, our second one is going to be similar in how we do it. So this one we have a much longer expression. On top, and then on the bottom, n squared, n to the negative 2 minus n to the negative 2. Okay, so here's our next one. So we have a much longer expression on the bottom, but this will hopefully give us some more practice in creating a complex with negative exponents. So one of the things that I notice right away in this first term is I need to move my negative to the denominator. And remember, we only move what has the negative exponent. So only the m has the negative exponent, so only m moves to the denominator. Same thing with the second term, only the n will move. On the third term, only the m has the negative, and on the fourth term, only the n has the negative. In the denominator, it'll become 1 over m squared minus 1 over n squared. So our first step of getting rid of the negative exponents by moving them to denominators. We then go to figure out our LCD. So the LCD here would be m squared n squared. So we multiply each term by m squared n squared. And remember, we have to do this to each and every term so that we can get rid of the denominators within the expression. So for the first one of the m's will cancel, leaving me with a m n squared. An n will cancel in the second one, leaving me with a m squared n. One of the m's will cancel with the third, so that'll leave me with b m n squared. And one n will cancel, leaving me with b m squared n. So there's my numerator after multiplying. And then in the denominator, the m squared cancels all the way, leaving me with n squared. And in the second term on the bottom, the n squareds will cancel, leaving me with an m squared. Okay, so now I'm going to look at how can I factor, because that would be my next step. So on top, I'm going to factor by grouping. So I'm going to group my two terms that have an A and my two terms that have a B. So when I look at my two groups on top, the first two, those look like they have an A, an M, and an N. And when I look at what's left, I have an N plus M. For the second one, they both have a B, an M, and an N. And when I look at what's left, I'll have N plus M. In the denominator, I'll have N plus M and n minus m because I have difference of squares. So I'm not quite done factoring this one yet, but I am going to move it up so you guys can see. So to finish my factor by grouping on top, I'm going to take out the GCF of n plus m, meaning I'll have a m n plus b m n left over. And so what I can do from here, I notice that I can simplify by crossing out the n plus m's. And something else that I noticed that I could have done right away and I didn't is that even with what's left, this a m n plus b m n, there's a GCF on top, mn times a plus b over n minus m. Either one of these I'll accept. This is the more fully factored, but again, if we were to distribute it, it's not going to make a difference. Factored, nothing cancels, so if you distribute it, it's the same thing. So again, depending on the type of question, will determine the form you want. So again, if it's multiple choice, pick the form that matches your options. If it's free response, I'll take either one. Now this problem in particular, we could have done it in a slightly different way, but we'd come up with the same answer. So if you're going through it and you think that you have a different way you'd like to try it and let us know. I'm always curious to figure out new ways. Okay, so I did have one more example that I wanted to do before we call it an end of notes. And that one is as such. not 6, sorry. Wrong number. 54. Okay, so this one here is to really test to see how well you know your exponent rules and what you can and cannot do. So one of the most common mistakes people make is they think, oh, there's a 3, we can put it through to everything. Well, that's wrong. That minus sign on the inside prevents you from doing that. If we had all multiplication in here, then yes, we could put the 3 through, but we cannot put this 3 through to both terms. So what I'm going to do to start this one is I'm actually going to start by simplifying these numbers here, the 45 and the 54. Those are just numbers. We can reduce them like any other fraction. So a number that goes into both 45 and 54, 9 does. So 9 goes into 45 5 times, and it goes into 54 6. And so one of the next things I'm going to do is rewrite 1 over x minus 1 over y to the 3rd power, and on the bottom I'll have 6 1 over x squared minus 1 over y squared. So I'm going to reduce the numbers first and then go ahead and get into my problem itself. Now, what makes this one a little bit different and how we might want to do it is because of that cubed, we can't necessarily do our LCD at this point. If you wanted to still do it that way, you'd actually have to go and multiply out 1 over x minus 1 over y times 1 over x minus 1 over y times 1 over x minus 1 over y and FOIL that all together. So this one I'm going to kind of go over a different method that you might want to employ when something like this happens. So rather than LCD, one of the things I notice is I have 1 over x squared minus 1 over y squared. These are both perfect squares, so this is actually a difference of squares. So if I use that pattern to factor my denominator, so I'm not going to do anything to the numerator, I'm just going to leave it. But my denominator, if I take the square root of 1 over x squared, I get 1 over x. The square root of 1 over y squared, I get 1 over y. So if I write that with a plus and then a minus, I notice something that I can reduce. Because my denominator is now fully factored, which means I can cross this 1 over x minus 1 over y. I can cross that out with one of those 1 over x, 1 over y's on top. So what that's allowed me to do is to get a smaller power on top, so when it does come to us needing to multiply, I now have one less thing to multiply. So now I'm going to be at the step where I have a 5, 1 over x minus 1 over y times 1 over x minus 1 over y, and then on the denominator I'll have 6 times 1 over x plus 1 over y. So now is the point where I do have to FOIL these two together. But by doing this step here first, and by noticing that difference of squares, we've made our multiplying step a lot simpler. So from here, I'm going to multiply these two polynomials together. So the 5 is still just hanging out front. So 1 over x times 1 over x will give me 1 over x squared. And then I'll have negative 1 over xy, and I'll have another negative 1 over xy, giving me a negative 2 over xy. And then lastly, two negatives make a positive, so 1 over y squared. In the denominator, I still have my 6 hanging around. I didn't need to do any multiplying, so I can just copy down what I have. Now I'm going to look for my LCD. So LCD here will be x squared y squared. So I'm going to multiply each term by x squared y squared. Now because the 5 and the 6 are being multiplied already, it would be, I don't have to distribute, but know that you also don't have to multiply those by x squared y squared. We're only going to multiply the added and subtracted terms. So if you distribute the 5, then it wouldn't matter. They'd still get multiplied by the x squared y squared. So we're only going to do the terms that are being added and subtracted. If you want to distribute the 6, you can, but you don't need to. Okay, so when I multiply here, the x squareds will cancel. So I still have my 5 that's hanging out there. I'll have a y squared. Here, the 1 of each will cancel, leaving me with 2xy. And the last one, the y squareds, will cancel, leaving me with an x squared. And then again in the denominator, the 6 is still hanging out there. And in the bottom, I'll have an xy squared plus x squared y. So what I'm going to look for now is any way to factor to try to simplify. So 5 is still hanging out there. The numerator will factor into y minus x squared. The denominator, I can take out a GCF of xy, and I get y plus x. So at this point, nothing cancels. So that means this would be our final answer. Okay, so just to kind of recap on this one, we started off in a slightly different manner as opposed to getting rid of the negatives and finding the LCD. Because of that cube on the outside, we got rid of the negatives, but then we factored a difference of squares so that we could try to make our exponent in the numerator a little bit smaller, so we would have less multiplication here. Now if you did not notice that, because that's something that might not jump out at you right away, you would need to multiply this expression 3 times in order to get it, and you will be able to get to the same result. It would just be a different path that you would have to take, and you would probably have some factor by grouping at some point, whereas we didn't have factor by grouping here. So same type of problem, just a slightly different step to start us, but we did get to that process eventually. So when you get to class tomorrow, juniors, you're going to have time to work on this. Seniors, there will be time on the block day when I see you guys, so on Wednesday, for you guys to do work on 6 and 7. We'll talk about how it's changed things tomorrow on the block day for you. But go ahead, make sure you have any questions noted so that we can go over them tomorrow.